Okay, we're going to start with Chapter 1 for our first lesson under Foundations for Geometry, Understanding Points, Lines, and Planes. Our objective for this lesson: identify, name, and draw points, lines, segments, rays, and planes, and we'll also apply some basic facts about those items. Make sure you follow along with your notes. Pause. If you have any questions, write those down, and we'll answer them as you come back to class. Okay, vocabulary terms. Here we have undefined term, line, collinear, segment, ray, postulate, that'll be a new one. Point, I'm sure you've heard of. Plane, and knot, an airplane. Okay. Coplanar, end point, and opposite rays. Okay, we'll go through and get some better definitions for these, maybe add a little bit to what you've known in the past. So, the most basic figures in geometry are undefined terms. These things cannot be defined using any other figures. The undefined terms we are working with are points, lines, and planes. These are our building blocks of geometry and for our study of geometry. Okay, we're going to use a table to kind of give some better definition to these undefined terms and have some diagrams to show you what they look like. So the first one, here in the corner, a point names a location. It has no size and is represented by a dot, which you will see over here in the diagram column. We represent points by this dot and name it with a capital letter. Okay, you need to be really paying attention to this. The way we diagram and name these parts of geometry is important. And if you were to use, for example, a lowercase letter to label a point, that would be considered incorrect and it would be graded incorrect. Okay, so pay close attention to the way we do these. The second one, a line is a straight path. It has no thickness, but it does go on forever. And in this case, we will label lines either with a lowercase letter or with 2 points that exist on the line. Okay, either of those conventions will work. You'll notice here these 2 points do exist on the line, and it can be labeled as XY, YX, or L. Okay, let's go on to the next one. A plane is a flat surface. It has no thickness, and it also extends forever. To label these, we can use one of two ways. We can use a script capital letter. Script is kind of like cursive. Or we can use 3 letters. Okay, now, we cannot use 2, and we do not formally use 4 letters. Okay, so even if you may see 4 letters on a plane, we would not use all of them. We only need 3 of those. Okay. All right. Points that lie on the same line. Points that lie on the same line are collinear. As an example here, you will see K, L, and M. They're all on the same line. Okay. The prefix co can mean something like with or together. Okay. Don't pay attention to my beautiful handwriting here. I'm doing my best here. So together, with or together, on meaning with or together on the same line, collinear. Okay. Now letters K, L, and N, those locations, K, L, and N, are non-collinear. They are not on the same line, non-collinear. However, points that lie on the same plane are called coplanar, meaning again, they are together on the same plane. Otherwise, they're known as non-coplanar. Okay? Pay close attention to things like prefixes. Okay? Things that will help us in context describe a term. All right, let's practice this a little bit. In example 1, we're going to work on naming points, lines, and planes. In part A, it asks us to name 4 coplanar points. Now remember, coplanar means they exist on the same or together on the same plane. An example of that would be locations A, B, C, and D. Take a look here. A, B, C, and D all exist on this plane. Okay, all exist on this plane that I'm highlighting with my cursor. Okay, so let's name 3 lines. Okay, now remember, we named the points just with letters. Okay, individual capital letters. When I name lines, we're going to name those with 2 letters, 2 capital letters. Okay, so let's check these out. AE goes from A to E in this pyramid type shape, A to E. We also have BE, okay, BE, and another one is CE. Now there's one additional possible answer that we could have. I'll let you try and determine what that is. Here's a check it out for us. We're going to apply what we've learned so far. Now this may be a little bit hard to see, but we want to name 2 planes. Okay, name 2 planes in this figure. If you need to refer back, you can pause the video, go back, take a look. How do we name planes? So one possible answer to this would be plane R, right? That's my capital script letter. Capital R is naming this plane that's in yellow. You could also name an additional plane, the one in pink, using 3 capital letters, A, B, C. Okay? Now, if you wanted to, or if you chose to do this, you could name plane R in an additional way. You could say plane and pick 3 of these points. Okay, 3 of the points are on that plane. Let's just say L, M, N would be an additional way to name that plane. Again, write down questions as you have them when they come up. Okay, moving on. Now we're moving a little bit away from our undefined terms. Those were our building blocks. So some other terms that we were going to look at today. A segment. Okay, a line segment is just part of a line, and the way we label it is with the 2 endpoints, both capital letters. There are not arrows now on the ends of my lines above those letters. Okay, it is important to pay attention to the way that these are labeled. Okay, notice it's A and B. That's just the segment of the line, a defined distance. Next one, an endpoint. Okay, this is a point that is at one end of a segment. Okay, or it could be at the starting of a ray. So again, just like a point, an end point is at the end of either a line segment or a ray. A ray. Okay, now this is part of a line that starts make note of this, it starts at an endpoint. Okay? In our diagram, that endpoint is R. Okay? And it extends forever in just one direction. Okay? So our second point, when we label this, we start with R. Pay attention, I have no arrow at that endpoint. Okay? The point that it goes through and continues on from will be the second letter. Okay? We're going from R to S. Okay, let's go on to the next term we have here, opposite rays. This is two rays that have a common endpoint and actually form a line. Okay, so the two rays, I have one starting at point E here, starts at point E and goes towards F. That is one of my rays. My second ray also starts at E and goes through G in the opposite direction. Okay, the opposite direction. Okay, now if these did not go in the opposite directions from each other, okay, if I had one that went to the left and then one that went kind of up and over, those would not be considered opposite rays. They would be two rays, but they would not be opposite rays. Okay? Okay, doing good so far. All right, let's practice drawing some of these terms. Let's try a segment that has endpoints M and N. So if you need to, pause the video, draw a segment with endpoints M and N, and then draw opposite rays with a common endpoint T. For part A, this would be a line segment with our endpoints M and N. Okay? And for opposite rays with a common endpoint T, there you go. Okay? Now some of you may have labeled a second point here that those opposite rays go through. Maybe R and maybe S. Okay, and that would be okay, either one. Okay, let's try another one. We're going to draw and label a ray that has an endpoint M and contains N. Let's take a look at that. There you go. Now some of you, maybe if you're left-handed, maybe you just saw it that way, you may have drawn your ray starting from the right and going to the left. Okay? And that would be all right also. Okay? But again, remember, when I label it, when I'm talking about it, it's going to look like this. Okay? That's my naming of that ray. Doing well so far. All right. Let's move on to our next term. This one I'm assuming will probably be a little bit new for you. This word is going to be called postulate, or another word for it is axiom. It's actually a statement that we accept as true without proof. Okay, we're accepting that it's true. Postulates about points, lines, and planes, those things help us describe other geometric properties. Okay, so that's why we need postulates to help us. So here's three postulates that we're going to be working with right away. Okay, and they'll be named this way: 111, 112, and 113. Let's take a look at those. Here, the first one, 111. Through any 2 points, there is one and only one line. Okay, one and only one line through 2 points. 112. If there are 3 non-collinear, meaning they're not on the same line, non-collinear points, there is exactly and only one plane that contains those. 113. If 2 points lie in a plane, then the line containing those points also lies in the plane. Okay? First 3 postulates. All right. So let's identify some of our geometric building blocks here. Name a line that passes through 2 points. Okay, well, remember, when I label this, I have to use the 2 points that exist on that line, and I'll include a line with arrows above it. Okay, so I would label it as XY with those arrows above. Let's name a plane here that has 3 non-collinear points. Now remember, there's a couple of ways we can name this plane. Okay, pay attention to all the different items we have in here. Looks like we have a line, we have some points. Looks like we're designating a plane here. How are we going to name that plane? One possible way would be with 3 letters, G, H, and F. An additional way would be using a script letter R. All right. Ooh, lots of words here. Okay, I'll help read through this. It says, recall that a system of equations is a set of 2 or more equations containing 2 or more of the same variables. The coordinates of the solution of the system satisfy all the equations in the system. These coordinates also locate a point where all the graphs of the equations in the system intersect. You may want to pause the video at this point and read through that a couple of times, highlighting some of the important pieces of information. Okay, one of those is going to be system of equations. Okay, things like coordinates, solution, and intersect. Okay, now that's a lot from Algebra 1 class. If you have questions on those, make a little note in your notes packet and we can talk about them when you come to class. Okay, an intersection, right? An intersection is the set of all the points that 2 or more figures have in common. Okay, now the next 2 postulates we're going to talk about involve intersections that deal with lines and planes. So let's keep on moving. All right. First one, 1, 1, 4. If 2 lines intersect, then they intersect in exactly what? One point. Try and draw that out for you. So 2 lines intersect at that 1 point. 1, 1, 5. Okay, if I have 2 planes, I'll try and draw this. 2 planes. Here's one. Okay. And then let me draw a second one here. Do the best I can. Oh, that's not too bad. Let's go over here. Okay. It's a little bit 3D-ish. They're going to intersect in exactly 1 line. Okay. There'll be 1 line. I got to redraw this for you. Okay. Right through there. All right. Okay, doing good so far. Next, little piece of information here. Use a dashed line to show any hidden parts of a drawing. Okay, it'll indicate that that is a hidden portion of your geometric image. Okay, so we want to sketch here 2 lines that intersect in exactly 1 point. Okay, I'll let you do that. And B, we're going to sketch a figure that shows a line that lies in a plane. Okay, so for part A, here we have 2 lines intersecting, easy enough. Okay, here's a plane that has a line that exists on it. Okay, and really you're just kind of drawing a diamond to illustrate a plane. Okay, sketch a figure that shows 2 lines intersect in 1 point in a plane, but only one of the lines is in the plane. All right, so if I started this, I would probably start by drawing myself a plane, then put a line on that plane and another line that's going to look like it's going through it. Okay, now this portion that's dashed is underneath of that plane that we cannot see. It will take some practice to do this. Okay, so if it's not perfect, it's not, you know, looking as good as you should, be patient. We'll get there and I can help you with that. Okay. All right. Here's a lesson quiz. This is not part of your notes. Okay. I would have you pause the video here, see if you can answer some questions on this lesson quiz. All right, here's some of the answers to that lesson quiz. You can check your work. And again, if you have questions, bring them to class. We'll talk about them if you got a mistake on the lesson quiz here, part 1. And we'll kind of get you straightened out, okay? Part 2 of the lesson quiz. Okay, again, you can pause your video and answer these questions. All right, we're back. Let's check these out. There's some drawings. And they may not be exactly as they're shown on here. Okay. All right. So that concludes lesson 1-1 for chapter 1, Foundations of Geometry. And we'll get on with going over these tomorrow in class and have some practice work to go along with it.